A universe of sets is the realm of objects that we're going to work with in mathematics. Any kind of mathematical idea or a question, problem can be encoded in the language of sets that the universe of sets provides. So it is basically a collection of abstract entities called sets. These entities can be displayed as dots. They are called sets. They can be given names. The names can be letters of an alphabet or other symbols. So for example, let's pick this object here. Let's call it X. So this is a set X. Now every set of the universe has contents, like ordinary sets in real life. But unlike real life, the contents of a set in a universe of sets are other sets. So it cannot be no other object except those that have already been decided to be part of the universe. For example, let's take this X here. Um, let's say that this X here has its contents, these two sets, and the sets that fall within a set like this are called elements of that set. So let's call them A and B. So in this display so far, we've got a set X, also other sets who haven't been given any names, but among them we have set that we've called X, and the set X has two elements. It's made up of two other sets, and these sets are called A and B. Now A and B themselves can be sets. For example, B could be a set that's made out of these three elements, and we can give names to these as well, or not. Let's give a name to one of them. Let's call this set Y. And also A can have elements. So let's say these are the four elements of A. Now in this display, it is crucial that the display is complete in terms of describing elements of the set. So in this example, the set A, strictly has these four elements that are displayed here, and no other set is an element of A, and the same for B. B has strictly these three elements. So let's give a name to one of the elements of A. Let's call it Z, and let's say this one, let's call that T. Now the set Y that we've got here, which is an element of the set B, let's say it has its elements, the same Z and T that are elements of A. So that's absolutely allowed. The same sets can be elements of different sets, and there's no problem with that. There we are. So we can see here, just to reiterate, we've got here various sets in the universe of sets. We've got set X. The set X consists of two other sets, A and B. Now the sets A and B together, they form a collection of sets, right? But they not form only a collection of sets, they also form a set. So it's actually one of the objects of the universe. Whereas, for instance, according to the display we made so far, there is no evidence that, let's say, a set consisting of B and Y, a collection consisting of B and Y, is an actual set in the universe. So for that to happen, there needs to be one of these dots that expand as the region BY. But at the moment, we haven't got that information, whether that happens or no. and we might decide that it doesn't happen. So this specific collection is no longer a set in the universe, whereas the blue, the red, the purple, and the green ones are. We can color this in with white color to perhaps indicate that this collection does not form a set in the universe. So going back to the display, we've got X, a set, and then it has two elements, A and B. And B is a set, it has three elements. Two of them haven't been labeled. One of them has been labeled, it's called Y. Y has two elements as well, Z and T. And now going back here, A has four elements. Among these four are Z and T. Now what about these elements here, the other two elements of B, or the other elements of A? So they could be having sets having further elements, or they could also be sets having no elements. So that's allowed. For example, this one here, let's call this one C. This could be a set having no elements, and this is how we will display it then. So you see we've got a region without any dots inside, and that indicates that now we have a set having no elements. We can color that in with orange color to distinguish it. Oh, that's not orange, this one is orange, or maybe red to distinguish it from the other one. So empty sets are allowed as well. And at this point, there is also, we're not ruling out the possibility that a set could have itself as an element. For example, there could be a set D having itself an element. So how would we display that? Perhaps like this. And also, we are not ruling out possibility of a set having identical elements, of two sets having identical elements. So that could be another set, not C, but R, for instance, also having no elements. Perhaps we can use the same color here for that. And it doesn't mean yet that R and C are the same set. When I say it doesn't mean yet, it means that at this point we're not putting that requirement, although later on we're going to put a requirement on universe of sets that will outrule the possibility of two different sets having identical collections of elements. So with the requirements we're going to introduce later on, sets R and C are actually going to be forced to be equal to each other. And further on, we might have a requirement that excludes the possibility of a set being an element of itself. So that's what a universe of sets is. And all of the mathematics can be developed within such a universe, obviously with some additional requirements on the universe, like the ones we mentioned before. And that's still further material to come on universes of sets.